Welcome back, students. We're going to continue with payments. Today, we are solving for the future value of a stream of payments. And I know what you might be thinking, didn't we already do this? But no, this is a different type of payment stream. These are known as an annuity due. Previously, we had covered ordinary annuity. So payments are broken up into two different types, ordinary annuities and annuity dues. Okay, so I will explain what an annuity due is. Why don't we go ahead and get started? So leave me your questions, leave me any time value of money questions, and I will solve it for you in a video. And don't forget, you can download this file and follow along. So quick overview. So I'm going to give you guys an introduction into any annuity due questions. We're going to be solving for the future value of this stream of payments. We're going to gain comfort with the begin mode in the TIBA2 Plus, the time value of money timeline, terms, and of course the use of the calculator. All right, so I typically don't like to lecture here, but I think it's important since it's a new concept. So remember, just like ordinary annuities, there are three elements to payments. It must be a series of equal payments. That means that if you say that payments are equal to, let's say, $1,000, that means that every single payment must be $1,000. It doesn't change. Okay, the payments occur at fixed intervals, so these happen every single year. Okay, and then the payments are finite, meaning that they do end. Okay, I covered this in the other one. I apologize if you're hearing this again. So let's get into the difference between an ordinary annuity and an annuity due. So on the left, this is our ordinary annuity, and on the right, this is our annuity due. Now, you might be thinking to yourself, what's the difference? It is subtle. The difference is here. Notice that on the left, the box on the right is missing, and on the right, the box on the left is missing. Well, so what does that mean, right? What does that mean? So I previously had gone over an ordinary annuity. Now, remember I mentioned this happens at the end of the year. So this is the first year, this is the second year, and this is the third year. And they happen at the end of each year. Now what is happening is an annuity due, first year, second year, third year. The annuity payment happens at the beginning of the year. At the beginning of the year. This point here is the beginning of the first year. This point is the beginning of the second year, and this point is the beginning of the third year. Now, you might be thinking to yourself, what's the big deal? Why does it matter, right? But it is a big deal, and I'll explain really quickly why. I don't want to spend too much time lecturing. But in your ordinary annuity, over here, your ordinary annuity on the left, look at this payment, payment 1. I'm going to label the other one as well, payment 1. Now, on the ordinary annuity, on the left, payment 1 actually gets to compound once, twice, 2 times, okay? Whereas payment 1 over here gets to compound 1, 2, 3 times. Payment 2 gets to compound once, whereas payment 2 here gets to compound once, twice. And then let's pick another color. Let's change this just to keep things consistent. Payment. Oh, why didn't that change? Okay. All right. Now payment 3. Notice this happens at the end, so there is no room for compounding, whereas payment 3 here has 1 year of compounding. So, you get an extra, there is additional compounding that happens when you get that first payment up front, and you can put it to work right away. So that's a really quick crash course on the difference between an ordinary annuity and an annuity due. Of course, for my class, I go way more into depth for this. But for this, I think this is good enough for you guys to understand the difference. If you have questions, please leave them in the comments below. All right, let's jump into our questions. Of course, we're going to start with grabbing our highlighter. You guys should know I have a pattern on how to solve these by now. And these questions are going to start to get a little bit more difficult because now we have a foundation on how to solve time value of money questions. So these will start to get a little bit more difficult, right? Let's jump in here. You want to save for a down payment on a house. You plan to deposit $9,000. Listen, look here. At the beginning of each year, this is what tells me it's an annuity due. This is what tells me it's an annuity due, okay? At the beginning of each year. This is the key word here, beginning. Okay, for the next 5 years, assuming an annual interest rate of 7.75%, here comes a question. What is the future value of this 5-year annuity due? So we're being told it's an annuity due. In this question, it's quite generous, right? We're being told it's an annuity due, which tells me I need to set my calculator. The mode must be set to begin mode, okay? Begin mode. All right, so what is it asking? Remember, what is it asking? Let's go over here to our terms. We're going to figure out what is the question. What is the future value? Okay, that is what it's asking. And now let's go from top to bottom and find the terms. So how many years are we talking about? So we're talking about 5 years. What is the interest rate? 7.75%. The present value, yeah, we don't have a present value in this question. And the payments, they're going to be $9,000 payments at the beginning of each year. They're payments, so it's going to be a negative. Now, let's fill out our timeline here just so that I can give you guys a visual. 5 years, 7.75%, zero present value. Future value is what we're looking for. And here I have my 5-year. Here's year 0, right? And there's going to be 5 payments. So let's grab, let's see here. Let me just. All right, so then let's put in our payments. Remember, the payments happen at the beginning of the year. So at the beginning of the first year, that's at time 0, we're going to have our first payment. And then at the beginning of the next year, we're going to have our second payment, and so on and so forth. And then our last one is at the beginning of year 5, 9K. They're all negative because they're payments. Okay. All right. So now we've set up our timeline, and we're going to try to figure out what is the future value of this stream of payments. So let's grab our financial calculator. Okay, we're going to second clear our time value of money. And before we get started, this is super, super important. We must set our calculator to begin mode. Okay, so how do we do that? We do second, and above payment, you can see it says BGN, and then we're going to do second set. Notice it says here set, and notice that's going to change it to BGN. Okay, BGN is up here. Now this is telling us, hey, your calculator is set to begin mode. The default mode is the ordinary annuity or the end mode. So it doesn't show it, but when you're in begin mode, it shows it here. Okay. All right. So now let's go left to right. Everything is the same after this. So 5 years. The interest rate is 7.75%. No present value, but let's put in a 0. Payments are $9,000 negative. And we're going to compute our future value of this stream of payment over 5 years at 7.75%. And that's going to give me $56,608.44. Okay, let's put that in here. 608.44. Let's just make sure that that's right. Yep, that is correct. And it is going to come back as a positive, right? You're making these savings payments, and after 5 years, you're expecting back to you. So it's a positive, right? It's coming back to you of $56,608. If you're still confused about that, I have a whole video about it. Okay. All right. So pretty straightforward, right? Now, keep in mind, I want to mention this. Even when you clear the time value of money, so you second clear and you clear your work here, your calculator stays in begin mode until you change that setting. So a lot of students make mistakes. They go on to the next question on the exam. They don't realize it's an ordinary annuity or that payments are being made at the end, and they leave their calculator in begin mode. This is horrible because you won't get the right answer. It will be a completely different answer. And to be honest, those wrong answers are often on my exam, so it's very easy to make that mistake. I don't do it to be cruel, but I do want to make sure you know what you're doing. Okay, let's go on to the next question. Let's grab our highlighter. So you're saving up to buy a new car. You plan to deposit $2,500 starting today, okay, for the next 4 years. That tells me it's a stream. It's a stream of payments, right? Assuming an annual interest rate of 9.55%, how much will you have at the end of 4 years? That's the question. How much will you have at the end of 4 years? So a little bit easier question, actually. So I'm looking for future value. The number of years is 4 years. Interest rate is 9.55%. 0 present value. Payments are going to be the $2,500 that I'm saving for 4 years. Okay. So 4 years, interest rate 9.55%, 0 present value, and I am looking for this future value here. Now this is 4 payments, so this would be pretty easy here. 1, 2, 3, 4. So we have your 0, our first year, our second year, our third year, and our fourth year. And the payments again happen at the beginning of each year. You need to think of this time here. This is January 1, and this is December 31, right? And then so on and so forth. Then here is January 1 of year 2. And then that's how it keeps going, right? So these payments are made on January 1st of each year, and they're going to be 2.5 thousand, right? Each one of them. We're making 4 payments. It's 2.5 thousand minus 2.5 thousand minus 2.5 thousand. Okay, so let's find what you would have saved. What your savings would have grown to, or your investment would have grown to after 4 years invested at 9.55%. Let's grab our financial calculator. Now, remember, we're already in begin mode, so we don't need to change it again. Notice it says BGN up here, okay? So I'm just going to clear my time value of money. Left to right, 4 years, 9.55%. Present value, we don't have a present value. Payments, 2,500. Negative because we're making payments. We're investing, right? And then we're going to look for our future value. So we're going to compute future value. We would have 12,626 and 60 cents. So 12,626 and 60 cents. Did I get that right? Yep. Okay. That's what this stream, right, 4 payments of 2,500 would have grown to, invested over 5 years at 9.55%. And again, I just want to cover this one more time because I think it's important. This first payment, right, gets compounded once, twice, 3 times, 4 times. And then the second payment gets compounded once, twice, 3 times. The third payment gets compounded 2 times. And then lastly, the last payment only gets compounded once. Okay, so all that compounding adds up to having a future value of 12,626 and 60 cents. Now, one of the big differences is this initial payment here, right? It's moved to the front, so you get that one whole additional year of compounding and growth. It's kind of important. It's what makes the biggest difference between an ordinary annuity and an annuity deal. Sorry, I feel like I'm rambling a little bit. But I hope you were able to catch some of that. Okay, let's go on to the next problem. Got my highlighter. You plan to deposit $12,000 per year for 8 years. Each deposit is made at the beginning of each year, right? This is key. That means our calculator needs to be in begin mode. In an account that pays an annual interest rate of 8.8%, and here comes the question, what will your account be worth at the end? All right, so first off, what are we looking for? What will the account be worth at the end in the future, right? Future value. And let's go through our terms here. Present value, future value, and then we have our payment here. Okay, so how many years? We have 8 years. Interest rate, 8.8%. The present value, well, there is no present value, right? We know we have a $12,000 for 8 years. So that's a stream. Now, if it said something like you are starting with $10,000 and you plan to do a stream of payments, then we would have something here. But since we don't, it just says we have 12,000 per year. Per year should tell us it's a stream, right? We know that that's going to be our payments. And it is asking, what is the future value? Of course, we know that there are going to be a total of 8 payments of $12,000, right? Okay, so let's grab our financial calculator. Right, let's clear that. Let's make sure first off that we are in begin mode. So it says here we are in BGN mode, so fantastic. Second, clear any time value of money. So left to right, we have 8 years, 8.8%. The present value is 0, and we're making $12,000 payments. Since we're making the payments, right, at the beginning of each year, it has to be negative. And then we're going to compute future value. So therefore, the future value, right, of our stream of $12,000 payments for 8 years, compounding at 8.8%, is going to be $142,948. $142,948. And what are the cents? And 54 cents. It's really a sort of straightforward problem. I hope you guys are getting a hang of it. Let's move on to the next problem. All right, so they're going to start to get a little bit more difficult. These next few problems are a little involved, but I think you'll get a lot out of these problems because this is what the problems will look like in the exam for me if you're my student, right? Okay, so your client who turned 25 years old today would like to start saving for retirement. So let's start highlighting. He has committed to investing $7,500 per year with the first payment being made today. That's what tells me it's an annuity due. Calculator needs to be in begin mode. If he invests in an index fund that provides a return of 10%, how much will here's the question, how much will his investment grow to by the time he is 65? So here I'm just going to do the timeline just in order to save a little bit of time, right? So number of years, interest rate, present value, future value. Okay, so I have, how many years are we talking about? So he's 25 and he wants to retire at 65. So that's a total of 40 years. The interest rate or the return that he's expecting is 10%. There is no present value, and we're trying to figure out what that stream of payments looks like. So let's put our negative 7,500, and there's going to be effectively 40 of these, right? 40 times 7,500. So what is this amount going to grow to? I'm not going to fill out the chart on the left. I think you guys understand at this point. So I'm going to second clear. I'm already in begin mode, so everything's good there. Let's just do left to right now. So 40 years, 10% interest, 0 present value. The payment We're making $7,500 every year. And we're going to compute the future value. So that amount of money would grow to 3.6 million, right? But let's, we want every single penny of what we put in, so we should put the whole amount. Okay. Let's see. 388.58. Okay, so we should expect 3.6 million or 3,651,388.58. I want every single penny of this if I've made the sacrifice of investing this $7,500, right, for 40 years at a return of 10%. Why wouldn't I? It's your money, right? You should get what you deserve. So pretty straightforward. Pretty straightforward question. I just want to check the number of years, check the interest, make sure I put in everything right. Okay, great. I hope that was a little bit tougher question. I didn't think it was anything crazy. Let's keep going. So the next question is based on question number 4. So your client decides to retire 10 years earlier than expected. So here's the question. How much should he expect there to be in his account? All other terms being the same. So this is simple. What we can do is we can go back to our n and say n is equal to 30, right? He wants to retire 10 years earlier. So how much money is he going to have? Future value. How much is he going to have if he retires 10 years earlier? So all we have to do is go to our financial calculator, and right now when we compute n, it's 40, so we can just change this to 30, put that in for the n, and then compute the future value. And look at that difference. Look at the last 10 years, right, are huge. So cutting off those last 10 years is a huge impact. So this is 1,357,075. Let's do this. How many cents are we talking about here? And 69 cents. Okay. So that is a huge difference. Look at this. Cutting off those last 10 years of compounding and investing has a huge impact on the final value or the future value. Okay, so that's the answer to number 5. And then number 6, this is going to get a little complicated, but bear with me. Number 6 is also based on questions 4 and 5. So your client would like to retire at the age of 55. All right, he already said that. He doesn't want to wait till 65. But based on your previous calculation, he has concluded that that is not enough money for him to retire on. So basically what he's saying is, hey, I want to retire, right, at 30 years of compounding. He's 25. This is his age here is 55 versus here his age would be 65. So this is saying, he's saying, hey, that's not enough money for me to retire on when I turn 55, 1.3 million, right? Let's highlight here. So based on your previous calculation, he has concluded that that is not enough money for him to retire on. He wants to retire at the age of 55. So he's insistent that he wants to retire 10 years earlier, but with the same amount that we calculated for the age of 65. So basically what he's saying is, hey, I want to retire at this age, but with this money, okay? So that's a big difference, right? He's saying, hey, I still want my 3.6 million. I still want my 3.6 million, right? So where's the question? How much more would he need to increase his payment to reach the same monetary goal 10 years earlier? So now this is a little complicated, right? So he still wants to retire 10 years earlier. So N is still going to be 30. The interest rate is still going to be 10%, right? The present value is still 0. And the future value is effectively this 3.651,388.58. Okay, so let's put that in here. So let me go get my cents. And 58 cents. All right, so I'm going to put it over here in the chart because I think this is important. Now we are looking for payment, right? How much more would he need to increase his payment to reach the same monetary goal? So N is equal to 30 years. The interest rate is 10%. There is no present value. And the future value is, I'm just going to put it at 3.65 million. You guys can see the full number over there, right? So how much more would he need to increase his payment? What is his current payment? His current payment is $7,500. $7,500. That's what he's currently putting in. But how much would this amount need to go up, right? How much more would he need to invest every single month to reach this goal? All right, so this is the variable we're looking for. This is my payment, okay? All right, so I know that, let's go back to our financial calculator. And I know that to get back to this number, I just need to change the 40N, then I can compute the future value, right? That's my original problem, 3.651. Now, he's still, let's just start over because I'm worried that I might confuse you guys by the way I'm doing it. I may not, but just for the sake of everyone, let's clear this. So we have our numbers here. Right, we have our numbers here. Let's do this. So 30 years, wants to retire 10 years earlier. The interest rate is still 10%. There is still no present value. Payments is what we're looking for now. That's a little different, right? And we have a future value of 3,651, 388, and 58 cents. That's a positive future value. So we're going to compute the payment. Wow, look at that. Okay, so $20,000. So let me put this in here. $20,179. What are the cents? And 73 cents. Okay, so what is the actual question? It says, how much more would he need to increase his payment? So we were paying $7,500, but now to reach the same goal 10 years earlier, we need to pay this amount, $20,179.73. That is a huge amount. So we would need to increase our payment. I'm gonna change this to positive, just so I can. Actually, this number is actually a negative from the calculator. I want to keep that straight. But I'm just gonna. Well, I guess I could leave it as a negative, and then I could subtract the. No, I need to add it. This is where it gets a little tricky. It's fine. We'll leave it at, because actually I just want to know how much we need to increase. The signs don't really matter. So I'm going to subtract the 7,500 that we were paying originally. Oh, what happened? Oh, let me go back. Compute payment. Okay, and then I'm going to subtract 7,500. And so this is the amount we would need to increase our payment by in order to reach our same goal 10 years earlier. So $12,679.73. Nope. Oh, sorry. What's going on? $12,679.73. Uh-oh. 679. And how many cents was that? I apologize. And 73 cents. Okay, that is our how much more we would need to save every year to reach our same goal 10 years earlier. So I know very involved, but if you can understand this, you are really on the right path. It's not it's not that complicated if you can keep everything in line. There's a lot of numbers, I understand, but give it a shot. Go back and do it again. Wait a day. Try it again tomorrow, right? When you're fresh. All right. A few takeaways. So keywords to look for when you're dealing with an annuity due. If it does say an annuity due, it's definitely an annuity due. If it says something like number of dollars at the beginning of each year, or the words immediately or starting today, those are kind of key words. Okay, so I just want you to take that away. This video probably went a lot longer than I expected, but there was a lot of good information here. I hope you got some value from the video. If you have any questions, leave me them in the comment section below, and I'll see you guys in the next one.